Here we have a non-conducting sphere made out of two layers you can see here, and at the innermost section from here center until here, we have a radius. Let's call this RA. This RA is equals to 6.0 cm. Now here have a charge density. Let's call this a rho A. Rho A will equals to negative 5.0 coulomb per meter cube, and we have another radius until the outermost surface, which is given by RB. This RB will equals to 12 cm, and the charge density here is equals to positive 8.0 coulombs per meter cube. So this is the basic information. First, we are asked to determine the electric field for this A from 0 until R until 6.0 cm. So as usual, we start with this Gauss law closed loop integral E dot dA equals to Q enclosed over the epsilon naught, and this area is the surface area of the sphere. So this is 4 pi r square, and this is what we call the Gaussian surface. So the r is arbitrary. This depends on where we define it. In this case, in the A case, we will define this between this 0 until 6.0 cm. This is not the same as the RA and the RB. So here we get this and Q enclosed. This is a 4 pi epsilon naught r square. So we back to here. We already know this E will equals to 1 over 4 pi epsilon naught, and this is Q enclosed over the r square. And in this case, you see we limit it, this r is less than 6.0 cm. That means less than this RA. In this case, you can see they are all enclosed by this negative charge, right? So we know the formula for the charge density. Rho is equals to the Q over V. So Q will equals to rho V, and this V is the 4/3 pi r cube, right? Now we substitute this formula inside the Q enclosed. This is rho. In this case, this row is a row A because this R is less than 6.0 cm. That means the charge enclosed will be inside this innermost section. This is 4/3 pi r cube. This is r squared, and clearly this count 1. So this is row A. This is 1/4 pi epsilon naught row A and 4/2 pi r, and this 4 pi can be cancelled out. We get row AR over the 3 epsilon naught, right? So we have the value of this row A and epsilon, but we don't have the R, so we just keep this R. This is a negative 5.0, and this is a 3 and 8.85, 10 to the negative 12. I get this is a negative 1.883, 10 to the negative 10 to the 11 Newton meter R, and the final unit will be Newton per coulombs. This is the answer for this question. Now we proceed to B. This B is 6.0 cm, and this R is between 6.0 cm until 12.0 cm. This we apply the same formula, 1/4 pi epsilon naught Q enclosed over the R square, and this will equals to 1/4 pi epsilon naught. This row A 4/3 pi R A cube, and plus row B 4/3 pi R cube minus R A cube over this R squared. Now you can see from here, actually this part here, right, is referred to the core volumes inside the innermost section. Now we already consider the innermost section. We are going to consider this part here. Remember this R is between the 6.0 cm until this 21.0 cm. That means if we draw this is the R here, right? Here another we enclose the charge is within this volumes, right? So the second term here you can see this R cube minus the RA. The cube is actually with respect to the volume that enclose at the region here, because this is quite clear. Here is refer to this R minus RA, right? But of course, because this is the volume, so this will become the R cube and minus the RA cube and multiply with the 4/3 pi. So by combination of these two with the upper part here, you will get the whole volume that enclose with this the R we choose. Now if we rearrange here, you can see this part here, this part here, and this part here is the same. So we basically rearrange it. We will get this is A rho A minus rho B, and for the 3 pi pi R square and plus rho B for 3 pi R cube. And R square, so this 4 pi we can cancel out and cancel out. So if simplify this thing, you will get this rho A minus rho B multiply with the RA cube over the PR square epsilon naught plus this rho B R this can cancel, we get 1 and over the 3 epsilon naught. Now we have all the value, we just substitute inside. Rho A is minus 5.0, 5.0 minus rho B 8.0, RA is 6.0, 10 to the negative 2 cube over 3 epsilon is equal to phi and square plus this rho b negative rho b is the 8.0 and r we do know this is 3.85 10 to the negative 12. Here I get this is negative 1.05 1.058 and this is a 10 to the 8 over the r squared and plus this 3.013 10 to the 11 r. So this is the answer for B. Now we go to the C. This C is given the R is between the 12.0 cm and 50 cm. So 12.0 cm and 50 cm. Now again as the formula before, here we know this is the RB and which the whole radius of the sphere. In this case, that means the Q enclosed is the total charge on the sphere, which given by this rho A 4/3 pi R A Q and plus rho B 4/3 pi R B Q minus R A Q. The whole thing over the R squared. Now we can simplify it, which this 4 pi can cancel and we simplify it, we get 3 epsilon naught r squared and above here is rho A minus rho B R A Q plus rho B RBQ. So we have all the value beside then this R. We just substitute. This is a 6.0 and multiply with the 10 to the negative 2 cube plus this 8.0. This is 1 2.0 10 to the negative 2 cube over this 3 8.85 10 to the negative 12, and this is r squared. Here I get this is 4.15 or 49 and to the 8 over this r squared, and we know the electric field is given by Newton per Coulomb for the unit. Well, of course, this is the case when we have the value for this r and we substitute it. Now we proceed to D. So D wants us to plot the this electric field for 0 until 50 cm and ask us whether the field continuous at the edge of the layer. So this is basically the graph for this E against the R. So we start with a 0 point. First thing, we take a look at the answer A first. You can see answer A here is proportional to the R. So, but since this is a negative, we know this is a linear decrease. Something like this. Let's say this is RA, and you will have a graph with linear decrease like this because of the negative. Now come to the range of the B here. We have this negative 1 over r square and plus this the linear r. So you can see here this term, the second term here actually is dominate the whole term, and this will cause some small decreasement, and due to this increase of this r, this will the first term here will decrease very fast, so you will expect the graph here should be look something like this. This is RB, and finally the last one C. You can see this is just 1 over the relationship is just per r squared here. So this is the graph we expect to look something like this. So this basically the answer for D, and what we can claim is that this field is continuous at the edge of the layer. The reason is you can see all the answer we calculate here, this R and R, all the this R are able to define the function which define this E, define all the E in their given range. So by this we can state this is continuous because all the point is able to define. Uh, this is the answer for this question.